So welcome to the lightning talks. This is the last session of PyData. First of all, we'd like to thank our sponsors once again. Especially, we'd like to thank Continuum. Continuum is our diamond sponsor, and Continuum is responsible for making a lot of what went on this weekend happen. So let's thank Continuum.
I just want to thank the committee, the local organizing committee. Can you stand up if you are on the committee? Bagmeet, Valentin, Philip, Sveta, please stand. Yeah, they might not be in here. Okay, just want to thank James Powell, also helped on there doing some review work, and the other people that helped on the review committee are not here, so we just want to give them a big hand. They put in a lot of hours.
We have about 5 or 6 lightning talks scheduled. So do you want to go first? Yeah. Okay. So first we have Valerio Maggio. I hope I pronounced that correctly. Talking about building a PyData community in Italy.
Okay, can you hear me? Yes, okay. Let's just, that's okay? May we start? Okay.
Go ahead.
This is the title of my talk. I prepared this talk this morning because inspired by the great keynote by Travis on building a PyData community in Italy. Actually, in Italy, we are a vibrant community of Pythonistas, and the organizer of the Python community in Italy from 2007 to 2010 organized 4 different edition of the Python Italian conference from PyCon 1 to PyCon 4, and we reached up to 400 attendees to these conferences. From 2011 and 2013, as you may already know, in Italy there have been EuroPython, so EuroPython has been hosted in Italy, in Florence in particular, and this year we had PyCon 5 in May, so the 5th edition of the Italian Python conference. The conference always has been held in Florence, in Italy, and these are the guys, or part of them, that organized these fantastic conference. They made, in my opinion, a great organization, a great work. This year also in Italy we had the Django Village. It has been the first time for a Django community in Italy to attend a unique conference explicitly dedicated to the Django web framework. So now it's for us the time to move ahead, and then we started thinking about, okay, but what about making a conference that may join different communities in order to build a broader conference, a big conference with different flavors inside it. So after saying that, we say, okay, might be a great idea to do this kind of conference. And then, so we're trying to organize the next edition of the Python Italian conference, which is the PyCon 6, that should host, of course, a Python track and a Django track. But now we would like to let you know that we will be really happy to host a PyData track inside this conference. The conference should be held tentatively on April in the next year, and will be held for sure in Florence. And if you don't know, Florence is the city of Assassin's Creed, so another reason to come, of course. And it will be great for us if we may add to this list of European cities of PyData, also PyData Florence for the next year. So thank you very much for your kind attention. Stay tuned on pydata.it. Actually, we tried to register this domain, but as Giovanni already tweeted a few minutes ago, we had some issues with the registrant. So please check this page out for tomorrow. But anyway, I will tweet about this in the next days. So thank you very much.
Thank you very much. So next up we have Adrian Gaydon, who will have a lightning talk about video analytics and computer vision in Python.
Oops. I need help with Max. I never actually attended a lightning talk, so be kind to me. It's my first Python conference ever. I'm a research scientist at Xerox Research Center Europe in Grenoble. So while this starts up, I can tell a bit more about what I do. So I do video analytics. So who here, maybe while it's getting up, who here knows about analytics, knows the definition of analytics? Nobody ever went to Wikipedia and typed analytics in Wikipedia? Okay. So I will show you the definition, and that way you will be able to use that buzzword in an industrial context, because in the industries, it's as hot a buzzword as big data.
Full screen. Full screen.
So Macs are very plug and play. Okay, cool. We're getting there. Okay, sorry about that. Right, so these are just some pictures of where I work out. It's Grenoble, I work out. It's a really nice city. Okay, video analytics. So analytics is the discovery and communication of meaningful patterns in data. For videos, it means, discovery means data analysis, like classification, so you can use scikit-learn for those kind of things. Communication means data visualization, something we discuss at length here. Meaningful patterns in video data means persons, objects, behaviors, events, scenes, those kind of things. So why video? I guess I can go quick over that, but there's hundreds of billions of online videos, hundreds of hours per minute uploaded to YouTube. We're talking about zettabytes of traffic. 2 million CCTVs in the UK, one for every 30 people. Lots of video. The problem is it's a digital black box. So it's just a bunch of pixels, and there's lots of research going on how to unbox. Many potential applications in transportation, healthcare, data management, and many, many others. And probably this is the most interesting to you. I use Python, and my colleagues at Xerox use Python a lot for computer vision and machine learning research. I insist on research. We don't make products, we make papers. And we use it for clean, object-oriented abstractions with scientific meaning, like a detector and tracker, and we use NumPy a lot. I really, really, really love vectorization and tensor tricks. One of my goals in life is to be able to use einsum of NumPy. Python, we use a lot. C, C++ with CFFI, FFmpeg, OpenCV, IPython parallel Python notebooks. Recently, Conda for dependency health management, because a lot of these things are not Python. And a lot of code which is not open source for now. And I just wanted to show a couple of videos highlighting recent results I obtained using Python, and maybe point to you to some open work that Xerox is doing on open.xerox.com. So let me show you maybe, I need to find out how it's sorted. Right, so it's not sorted alphabetically, apparently. Okay, so what I'll show you is the end result of what we can do. Hopefully it works. So this is typically the output of the algorithm we want to have for action recognition. So for actions, action recognition in videos means trying to tell what people are doing inside videos, and as I said, it's a black box. So what we're trying to do is unbox it, and unboxing means, in this case, adding nice colors, which correspond to actually motion parts that we can understand, and we can feed that to machine learning algorithms to recognize what are actions. So I'm sorry, this is very rough. There were other videos I wanted to show you, but I think I'm running out of time. And so feel free to come and I will show you lots of cooler videos. I think I have 20 or something. So I hope it was okay for a lightning talk.
Okay, thank you very much. The next speaker, Felix Zumstein. Okay, then after that, Isaac Bernat about PyCastrinate. Is that correct, or PyCastrinate? How do I pronounce it correctly?
Okay, so hello everybody, my name is Felix, I do Python for Finance. And for those who have seen me on Monday at the EuroPython giving a lightning talk, I'm sorry, it's going to be exactly the same. The good news is it's going to be over in just 5 minutes, so I hope it's not too bad. I'm going to talk about two packages, they're called XLWings and XLPython. As you probably figured, they're dealing with programming Excel from Python and interacting with Excel from Python. And XLWings is my own package. XLPython is a package by a guy called Eric Reynolds. And the good thing about those two packages is that they cover together pretty much everything you ever wanted to do with Excel. So they're pretty complementary. And that's why we are actually talking together and we want to integrate them into one package at some point when they are mature enough. So I'm going to start presenting XLWings, and actually the next version I'm expecting it to be out next week, because it's going to add support for Excel on Mac. So the first package actually in the Python stack that supports Excel natively on Mac. So it's easy to get started. You just create a workbook object from XLWings. You just import XLWings. By the way, the homepage is xlwings.org. There is also a link on to the other project, XLPython, and then it allows you to, it allows you to interact with Excel pretty much the way you're used to natively from Excel VBA. You can also read the values back using index notation. You can deal with date times. You can, target various cells at the same time. You can also carry over whole tables as nested lists over here. It takes care of the non-types, transfers them into empty cells. And you can also use the property table to read back a whole contiguous cell array again. So very easily to, juggle back and forth data from and to Excel. Then it interacts also very nicely with matrices from the NumPy arrays. It sends them over, and if you want to read back in directly NumPy arrays, you can also just specify the asArray keyword here, and it takes, again, the cells from over here, translating empty cells into NANs. Then pandas data frames is actually pretty much the same. You can just read in the data, you split off, I'm going actually from here, from A6. You can split off the headers here into the columns, and the rest is the data, and then it's going to get you very easily back your data frame. And the same story again, if you want to put it over into Excel, just assign it to an upper left corner, and you also have the possibility to control index and headers individually. Finally here, you can also have a one-liner for creating Excel charts and set the range and chart type. So that's what's currently, or what will be available in the Mac version from next week. Now I'm on Windows, we have a lot more features here. We have also a possibility to call these macros or these scripts that you can write using XLWings. You can call them from within Excel, so it really behaves like a macro. There is a native way currently in XLWings, but if you connect it together with the other package, with XLPython, it's extremely fast, so it's very, very much more efficient. Then XLPython gives you on top, and from now on I'm really just showing you the functionality from Excel Python. It gives you a way to access existing Python code without having to change the Python code. So no decorators, no nothing. And the good thing, you can use this, for example, for functionality that's not available in Excel. So if you want to build an inverse, then you have the inverse function in Excel, but if you have a singular matrix, then that's not going to help you. So it would be good to have a p-inverse function, the one from from NumPy. So there's a way to expose that in Excel using Excel Python. You build a little wrapper, and it looks a bit weird now. It's a lot of code, but there's actually a developer add-in that can do the code for you. And the last thing I want to show is there is a possibility to also expose user-defined functions from Python. So I did quickly a portfolio covariance matrix. It's in native Excel, it's 2 matrix multiplications, 1 transpose. And if you apply this here using a large enough matrix, so 400 by 400, then this on top is the result. So if I change the input, it takes a very long time in Excel to calculate that, just because the matrices are fairly big. If I do the same here using Excel Python, not only the formula is simpler, but it's also very quick in calculating it. That's about it. Thanks.
Thank you very much.
Hi, I'm going also to present some lightning talk that was being presented in Python in EuroPython. And this is basically a stripped-down version of a talk I did on PyCon Sweden this year. It's not super data-driven, but it has some data parts in it. I hope you will enjoy it. And there you go. So, whoops, a bit too much of Zoom. So basically, this is a tool that you would use on your code base to analyze and make sense of all these to-dos and fixes you have. You can use it to extract some metadata, like who committed it, when it was committed, and then with this metadata you can play around. So this talk would be structured, talking first on the tool, then some use cases on where you can use it. And if you want a deeper version, you can go to the GitHub link here, where I have more documentation and also the longer version of the presentation in PyCon Sweden. But because we are in a lightning talk, and I don't know if I will have time for everything, let's just start with the conclusions. Why do you want to use it? First of all, it's convenient. You don't have to change the way you're programming in any way, and you can use it out of the box and in any language. I know that here we all use Python, but sometimes Python is a good language and you're dealing with some more things. You can use it. Secondly, the only dependency it has is Python 2 and Python 3, no weird libraries. It's very modular. So right now the modules it has are very basic, but for example, if you like to build some machine learning solution to compare the number of to-dos and fix-mes if they correlate with the number of weekly bugs you discover, this could be a good approach. And it's fast. It's not super fast as some machine learning tools we have seen here, but it's fast enough for a real use case. For example, I used it on Django because it's a popular library we all know, and it's relatively big, 250K lines of Python, because I'm only looking at Python files. And I found more than 60 fix-mes and to-dos, 20 of them more than 5 years old. So even if it's a very supported and reputable library, we see that this is a problem, and it needs to be addressed. Probably our own code bases also have similar problems. But here you can see, I'm going to run it. It's just 3 seconds. I was not kidding. And here you get the results. This is the plain console output version. It also has a HTML output version, and it's modular. If you want to write one for LaTeX, you can do it. And basically here I'm aggregating the different types of tokens and then the authors. And then here there are several columns that I configured here, which ones I wanted to see. And also I can configure which kind of aggregation. It's quite flexible. So, having now the conclusions, I'm going to talk about the pipeline, which is the main skeleton of this program. Basically, there are 8 different parts. I classify them like this, and you don't need to do them. And also, you can do more than one step at once. For example, in gather files, you would decide which files you want, as easy as typing your repo and the file extension. In spec files, in our case, we would use some regular expression to get all the fixmes and to-dos. We could extract more metadata, apart from the date, for example, the weekday, maybe it's important. And then we can also filter our results. For example, if one developer is out on vacation, maybe we don't want to bug him about some to-do that's going there. Then this is a bit more analysis, so we can trigger actions. We can, for example, make our continuous integration server break if we have some rule that we don't want there. We can aggregate the data to make it easier to understand, generate automatic reports and notifications. This is just an implementation detail, process results, because almost everything is lazily evaluated. You have to process the results in the end, or you would get nothing. So how do you configure this and use it? It's very easy. You just need a dictionary in the configuration file. And the key would be the priority, the order in which will be executed. And the other are some of the different functions or modules that are available. And then, with a different dictionary, you just fit which parameters you want to fit into them. Here, there are just a few. They are much more configurable, but usually defaults are enough, so you don't have to include them. Now, we are done with the tool. I will explain just one use case, because I think I'm running out of time. And let's imagine we want to take control of a code base that's scripting with fixmes. What would we do first? First, we would search for fixmes. I think everybody agrees on that. And then, for example, we want to filter those that are very old and those that are more or less recent, a couple of weeks. Why not just take off fixmes? For example, if your code is breaking in production, it may be reasonable to do some ugly hack to make it work again in production. But we don't want all our code after this to be relying on some bad code. So maybe after 15 days, it's a good indicator that this should not be here. We should fix it. And we will email a report to the committer and maybe to the repository repo owner as well. So we just need to add 2 more lines of code to the code we previously saw, this exclude and send email modules. This exclude module, basically you can just use any token you want, you write your own Lambda function and evaluate it, and you can filter out those results. And this is the amount of code it will take. I think I've run out of time. Here you have some more examples. You can see them, and yeah. So to conclude, to do, it doesn't necessarily mean that will be done, it just means that it's not done. So make to do really mean what we want and get rid of them. Thanks.
Okay, thank you very much. Next up, Benjamin Wilson. What's the title of your talk?
I haven't really got one. It's a little bit of a show and tell. It's about the archive. I'll just go with it.
By all means.
There we go. Well, I won't show you that yet. Hello, my name's Benjamin. Who has heard of the archive? Repository for scientific articles? A few? Oh, that's good. That's what I was hoping. Because what I really wanted to do was just show you something useful we built for a demo. Hoping to get you to use it, and maybe you'll find it useful and you can use it every now and then. So, for those that don't know, the archive is a repository for scientific articles. So, well, subfields particularly of mathematics, computer science, physics. There's about 1 million articles on there. They're all very recent, but it has become increasingly important. It's really changed the way we publish scientific articles. So I'm a mathematician, or at least I was. I used to use it a lot. I still do to some extent. It's a fantastic resource It's great if you know which paper you want to find, but if you just want to explore, it's no good at all. It really doesn't even try to give you that functionality. I now work with, together with another mathematician, Steve, who you might have met, at a company called lateral.io, and we try and extract meaning from text. And we had to build a little demo just to show we weren't complete monkeys. So we built one and we used the archive data, and we're going to keep it up to date. And we've just put it out there because we thought it's actually really useful. So this is what it looks like. What it looks like is also a work in progress. But just to give you an idea of what it does, so I recently did some work on Word2Vec. So we find a paper by Mikolov here. Up the top, you've just got the information you got from the archive, but down the bottom, you've got related articles. So these are articles that our system believes are semantically related. Now, I don't think the recommendations, I think they're very good, or they're at least good. We can certainly make them a lot better, but I think it's already at a stage where it's really useful. So if you like it, feel free to use it. That's all I wanted to say. So the address is archive.lateral.io. Thanks.
Yeah, that looks really useful. Thank you very much. So next up is Alex Savio, who is going to be talking about PYSS 14. Or is that perhaps pronounced differently?
No, it's all right. Correct. Thanks. Sorry, it's Spanish. Sorry. Yeah.
See, I really wonder why it's always such an issue to get your laptop connected to your Beamer. I thought, you know, these things might have been worked out by now. You just sort of walk up there, connect it, and go, but... Ah, there we go.
Well, hi. I just prepared this in 5 minutes. We are from San Sebastián in the north of Spain, the rainy part. We are from the computational intelligence group in the University of the Basque Country. We have been working a lot with computer vision, medical image processing, hyperspectral imaging, in MATLAB. But lately we have been working on Python. We are trying to build a small Python community in the faculty and in the area, and we plan to do a meetup in San Sebastián. So we have a very nice venue. We have experience doing conferences, organizing conferences. We have a very nice building in the university to do that. It's in front of the beach. So we are also going to a cider house, and well, we might have something for the vegetarians as well. Yeah, we just created a Twitter account for this. We are still deciding on the dates. Yeah, so please, it's going to be in September, October, depends on when the cinema festival ends. So everyone is welcome, and thank you.
Thank you. So I need to ask you: is the name intentional? Is that is there a hidden joke there?
Yeah. Well, we voted for the name. It's not definitive, but I mean it's a good candidate.
All right. Well, thank you very much. So now we come to our last, at least the last lightning talk on the schedule. So if you do want to give a lightning talk after this, just whip one out. Feel free to just come up here and wait. So the next talk is by Sylvain Bellamer. I hope I pronounced that correctly. Okay. Sylvain. Okay, Sylvain Bellamer. And it's going to be about provisioning the SciPy stack with SaltStack. Is it SaltStack?
Yeah, but it's a bit of a pretentious title. I just made it up now. Because this is totally improvised. I'm totally new to data science, SciPy, and NumPy. I'm just a software developer working with Python, Django for a bit more than 2 years now. So I was a bit not suspicious or not skeptical, but curious to see how difficult it is to install SciPy or NumPy. So I decided not to use Conda or Anaconda or Miniconda right away. I decided to try to install it myself, like using pip or something. So what I ended up doing, just Friday, Saturday, and today over a conference in my free time between the very tight schedule, is to provision a small virtual box, like with Vagrant and using SaltStack. So I thought I'll share that because if you happen to be curious and to see or want to control more your environment or something or play around, I thought it could be useful to you. Oh yeah, today there was this talk about Conda by Ilan, I think, from Continuum Analytics, and he was mentioning that, for instance, installing H5Py was a bit difficult, you know. So I decided to try to do it this way with SaltStack and VirtualBox. So it works. Maybe I show you instead in the terminal. So I won't do it because it takes a lot of time the first time you build it, but once you SSH to the VirtualBox, let's say if I start the IPython notebook, specify you can grab, before doing that, usually what you would do, you'll run ifconfig to know what's the IP of the virtual machine, and then after that, you'll run without the browser, and then you go to the host machine, and let's say this is a notebook. Now, and just to check, okay, is everything really installed? Seems that yes. So that's about it. I mean, there's no, okay, now if you want to know, maybe if you're curious to know what's behind that, there's a Vagrant file, that's a salt state, and this is where stuff is happening. So, I mean, I don't know if you don't know about SaltStack, it's new to me too. I find it very useful, very clear. So you just specify what the state that you would like the machine to be in, you know, which package should be there, which packages should be there, and then the virtual environment is being provisioned. I saw yesterday that some guy developed a salt state module for Conda. So that means instead of using virtual environment there, you could use Conda to provision also your. So I think many of you, it seems here, or really like to use Conda and Anaconda. But let's say you wanted to do that just locally, spin up a virtual machine to test some stuff, and because the thing that is really useful with that, you can easily destroy and recreate the machine. The problem with that, it will take time. Maybe, especially with a SciPy, it may take like 15, 20 minutes, but still, you can have many virtual machines that you can experiment with if you want to. And you can move that easily towards Amazon also, if you wanted to provision like Amazon servers, you know. There's a Vagrant or there's SoundCloud also that you could use. So that's, I mean, it's not planned, you know, I just decided I wanted to share what I did a bit over a weekend besides attending the talk. So I don't know, in case it would be useful to some people. So that's about it. I don't know. If you have questions, you can ask me.
Okay, thank you. Right, so I guess there's no one else wanting to give another lightning talk. Alrighty, so that's it for the conference. Thanks again to all our sponsors, Continuum, AdSquare, Minodes, Immobilien Scout, Clicks, Blue Yonder, Backdata. So I hope I have all of you. Minodes, I think I mentioned them. And special thanks to all of you attendees. This is sort of always the most important part of a conference, is actually the people that attend. You know, otherwise there would just be sort of speakers on stage speaking to an empty room. So give yourselves a big hand. Thanks again to all of you for attending. I hope you had a great time.